Hello everyone. Through this class, we are going to study about analog to digital converter counter type. The process of changing an analog signal to an equivalent digital signal is accomplished by the use of an analog to digital converter. An analog to digital converter is often referred to as an encoding device since it is used to encode signals for entry into digital system. Counter type analog to digital converter is composed of a digital to analog converter, one comparator, a clock, a gate, and a control circuitry. Figure shows the simplest method of analog to digital conversion. Here we can see one op-amp. This op-amp acts as the comparator. The analog input given is V in. Then here we have one digital to analog converter, then 8-bit counter. Then we have a clock signal here. Here the output digital word is D7, D6, D5, D4, D3, D2, D1, D0. Here in this circuit we have a start pulse. This is our start pulse. When start pulse is low, here we can see that this is actually clear bar. Clear bar low or 0, that means clear is high or 1. When clear input is high, it will clear the contents in the counter. So the output of this counter is 0, 0, 0, 0 up to this one, it is 0. Now the output word of the counter is 0. When the start pulse changes into high, it is ready for conversion. And it can count when the control input count, C count, is high. And when the output, initially the output of this counter is 0. So that 0 is the input for this digital to analog counter. And here we can see that there are 8 input bits corresponding to 0, 0, 0 up to this last one 0. So the output word of this 8-bit digital to analog converter is also 0. That is actually our V out. So initially V out equal to 0. So if we apply an input V in which is positive, then that is applied to positive terminal of this op-amp and V out, that is 0 to negative of the op-amp. That op-amp compares both inputs, and here V in is greater than this V out. Therefore, it sets a high output. So the output of this comparator is high. That is our C count. Now we can see that the control input for 8-bit counter is high. So when clock arrives, now this counter starts counting from 0. When count is 1, if the first positive edge of the clock arrives this 8-bit counter, it will set its least significant bit output D0 to 1. All the other outputs, they are 0. Second positive edge of the clock arrives, it will set the output line D1 to 1 and all the other output lines to 0. When the third positive edge of the clock arrives, D1 and D0 are set to 1. In this way, when count is 1, each clock pulse arrives, 8-bit counter will set its output lines. Since the output of this counter drives the digital to analog converter, the converter output is a positive voltage staircase like this. So when D0 is 1, there is a voltage level. When D1 is 1, then another high voltage level. D1 and D0 are 1, another voltage level. So like this, V out gradually increases. When V out gradually increases. Here we can see that this is one of the input for this comparator. So this comparator will compare voltage level V in with this V out. If V in is greater than V out, the output will be high. That means count equal to high. So this counter will count if the count is high or 1. Once V in is less than this V out, the output of this comparator will be low. That means C count equal to 0. When C count equal to 0, this counter will stop counting. At that time, we have a particular output D7, D6, D5, D4, D3, D2, D1, D0. That is the digital equivalent of given V in. The negative edge of the count signal is used as an end of conversion signal. This tells other circuits that the analog to digital conversion is finished. If the analog input V in is changed, the external circuit must send another start pulse to start the conversion. This clears the counter and a new cycle begins. When the digital data is ready, the end of the conversion signal has a falling edge again. For convenience, an 8-bit digital to analog converter and 8-bit counter are used here, but this idea can be applied to any number of bits. The counter type analog to digital converter provides a very good method for digitizing. This method is much simpler, but the conversion time required is longer since the counter always begins at 0 and counts through its normal binary sequence.